Now we're going to keep looking with conditional probability, but now we're going to look at it through a little different eyes. And what we're actually looking at here is this idea right here. The probability that A given B is not the same as the probability of B given A. And we're going to look at this example here with the Beardstown Bearcats. We know that they play 60% of their games at night. So we're going to write that as 0.60, which means they have to play 40% of their games during the day. Then it tells us here, of the games they play at night, they win 55% of the time. And of the games they play during the day, they only win 35% of the time. So what we basically have here is win given night game has to be 0.55, and the probability of winning given a day game is 0.35. What I want to do here is I want to bring back the tree diagram that we talked about earlier. So I know that the Bearcats have two choices, either a night game or a day game. From the night game, they can either win or lose. From the day game, they can either win or lose. They're the only possibilities. Well, this W up here would represent the probability of them winning given there was a night game. So what that's going to end up doing is, if I have the probability of it being a night game and a win, that's going to be equal to the 0.60, the probability that it's a night game, times the 0.55, which is the probability that they won given that it was a night game. So it's going to end up being 0.33. I'll be able to do that for every single one of these. So the probability that they had a night game and lost, well, the night game's still 0.6. Probability of them losing would be 0.45, the complement. It's going to give me 0.27. Probability of a day game and a win. Probability of a day game and a loss. The day game we have up here as 0.40. Multiply that by 0.35. Day game 0.40. Complement of 0.35, which is 0.65. And there's my answers. So what we have now, and this information over here, is the information that we're going to use to come back and use Bayes' rule. So all we did is we fleshed out our information. We have conditionals, and now we have the AND statements. And we know from conditional, the AND statement's huge when it comes to figuring out what the conditional happens to be. So now that we have that information, let's go up here and actually look at the question that's being asked. And we're looking at what's the probability that this game was played at night knowing that they won. So what we're looking at is what's the probability that it was a night game given a win. Well, up here they gave us the probability of win given night game. And that was the 0.55, the 55%. These are not the same thing. And that's what we talked about at the top. So for me to figure this out, I actually have to go back to my formula, which is the probability of N and W over the probability of W. So what we realize is the probability of winning is actually the probability of winning and a day game, the probability of winning and the night game. So if I rewrite this over here, my denominator is going to become this. Probability of winning and night plus the probability of winning and day. Well, I have all those numbers. I have the 0.33. And I have the 0.14. when I put that together and do my division, I'm going to end up with a 0.70. So in this particular case, what's the probability that the game was played at night? Given that they won, and that's all we're talking about right there, 0.7.